written an article on the greenhouse effect. It was a year-end article. They wanted me to pick out the most important scientific event of 1988. And I really thought that the most important scientific event of 1988 would only be recognized sometime in the future when you get a little perspective. But I thought that the most interesting scientific event of 1988 was the way everyone started speaking about the greenhouse effect just because there was a hot summer and a drought, when I had been talking about the greenhouse effect for 20 years at least. And there were other people who talked about it before I did. I mean, I didn't invent it. So I explained what was meant by the greenhouse effect, and I also explained that not only were we constantly pumping carbon dioxide into the atmosphere because we're burning fossil fuels, coal and oil and gas, so that the content of the atmosphere, as far as carbon dioxide is concerned, has been going up steadily, not very rapidly, but steadily, ever since 1900. And it's continuing to do so. The amount of carbon dioxide in the atmosphere now is 50% higher than it was in 1900. It's still only a little over 0.035%, which is not enough to bother us as far as breathing is concerned. But it's enough to trap the infrared waves that Earth reflects into space and to raise the temperature of the Earth slightly. The temperature will keep on going up. And not only are we piling in more and more carbon dioxide in the atmosphere, but we are chopping down the forests of the Earth at a great rate. And the forests themselves are the most efficient consumers of carbon dioxide that there are on Earth. Anything that substitutes for the forests, like, let us say, grain fields or grasslands, are not going to consume carbon dioxide as efficiently. And if we replace them with desert, which is most likely, it won't absorb the carbon dioxide at all. So that, in a sense, we are contributing to the greenhouse effect in two ways. By pushing the output of carbon dioxide and inhibiting the input, so to speak.
Other scientists who are stationed at the South Pole, Alaska, Hawaii, and Samoa are studying another factor that may affect the climate of the future: the increase in carbon dioxide in the atmosphere. There is evidence that carbon dioxide produced by man may be altering the climate by changing Earth's energy balance. Some call it the greenhouse effect. Dr. J. Murray Mitchell is senior scientist for the National Environmental Satellite Data and Information Service. He talks about the greenhouse effect.
One of the ways in which man's activities might influence future climate is by the prodigious quantities of carbon dioxide gas that are released whenever we burn natural gas, gasoline, coal, any other material like that, fuel, that is mined out of the ground. We believe it's very realistic to expect that within the next 100 years, the amount of carbon dioxide naturally in the air will be doubled by all the fossil fuels that we will be burning in the meantime. A doubling of carbon dioxide may very well warm the Earth by something like 2 or 3 degrees Celsius. The basic idea is that carbon dioxide is transparent to sunlight pouring down through the atmosphere to warm the Earth. But it is not transparent to heat radiation, which is welling back up from the Earth and trying to dissipate that heat into space. So it's like the glass in a greenhouse, where glass is also transparent to sunlight coming through, but it's opaque to heat radiation trying to escape back out of a greenhouse.
If the global temperature rises, it would shift the climatic belts on Earth. It would change the rainfall patterns. It would change, again, it would influence, again, the crops. And actually, we cannot predict with any precision what would happen. But there are a lot of people working on that problem.
Isaac, we've been talking about a lot of words this year that most of our listeners may never have heard before. Do you have one that's become common in our everyday language?
Well, how about greenhouse effect? We know what a greenhouse is. That's a very common thing. Now, as you know, a greenhouse is made almost entirely of glass. And you figure, why glass? And the answer to that is that glass is transparent to visible light, but not so transparent to infrared light. Infrared light is like visible light, but it's got longer waves. The longer the waves, the less energy it has. Now here's what happens. The high energy visible light from the sun goes through, and it heats up whatever's inside the greenhouse. Whatever's inside the greenhouse re-radiates energy, but at a lower energy intensity. So it doesn't re-radiate visible light, it re-radiates infrared. And that won't go through the glass very well. So the heat is trapped inside the glass. The sunshine comes down, gets inside, stays there, so to speak, so that the temperature inside the greenhouse is always higher than it is outside. And you manage to keep the plants growing even when outside it would be too cold for them to grow. Well then, anything which has this effect of allowing visible light to pass and being a barrier to infrared is said to have a greenhouse effect. Mm-hmm. Now, one of the substances that has a greenhouse effect is carbon dioxide. Carbon dioxide is transparent to visible light, but it absorbs infrared. It acts as a heat trap. Now, in our atmosphere, there's 0.03% of carbon dioxide. This isn't much, but it's enough to trap some heat and make the surface of the Earth warmer by a little bit than it would otherwise be. Now, when we are burning fuel at all times, coal and oil, we are always pouring carbon dioxide into the air. Some of the carbon dioxide dissolves in the oceans, some of it reacts with certain chemicals in the soil, but there's enough that gets into the atmosphere so that it's going up slightly. And possibly by the time, say, another 50 years or so, it might have, instead of 0.03%, it might be 0.05%. Well, we'll never notice a difference. Carbon dioxide isn't particularly bad for us in that small quantity. We'll just breathe, but it's going to stop enough extra heat so that the surface of the Earth might be just a degree or so warmer on the average than it is now. Well, this too isn't too bad. We could manage. Well, the summers will be a little warmer, the winters a little milder, but the peculiar thing is that perhaps just this little additional heat on the Earth generally might suffice to start melting the ice caps. In other words, right now they melt a little in the summer and they freeze a little in the winter. There's a balance. But if the Earth gets even just a little bit warmer, maybe a little bit more will melt in the summer, a little bit less will freeze in the winter, and little by little they'll start melting. And all that water will run into the ocean and raise the level 200 feet and drown all the coasts. So that this greenhouse effect can be very serious, and it's something that we have to take into account as we're working along. Now, the planet Venus has a thick atmosphere, which is 95% carbon dioxide. It has a runaway greenhouse effect, and the temperature on the planet Venus is something like 500 degrees centigrade. It's hot enough to melt lead, entirely because of the heat trap of the atmosphere.
That really worries me because my wife and I live right on the ocean, on the Pacific Ocean.
Well, I need not say that New York City is right in the Atlantic Ocean.
Right. What was the concern a while back with the SST, that it might increase the greenhouse effect? What was the argument there, do you know?
Well, the SST would release, see, carbon dioxide isn't the only molecule that acts as a greenhouse effect. There are other complicated molecules that do so also, nitrous oxide, methane, and so on. But they are present in the atmosphere in far smaller quantities. But
the SST can release these molecules in the upper atmosphere, and even small quantities can trap a little bit more heat. Also, they can react with the ozone layer, so that it also might threaten the ozone layer. This is not something which is absolutely certain, but some scientists felt we oughtn't to take chances like that either.
Thanks a lot, Isaac.
This planet is threatened with destruction, and we who live in it with death. The heavens reek, the waters below are foul, children die in infancy, and we and the world, which is our home, live on the brink of nuclear annihilation. We are in a crisis of survival.
This is a CBS News special, Earth Day, a question of survival, with CBS News correspondent Walter Cronkite.
Good evening. A unique day in American history is ending, a day set aside for a nationwide outpouring of mankind seeking its own survival. Earth Day, a day dedicated to enlisting all the citizens of a bountiful country in the common cause of saving life from the deadly byproducts of that bounty, the fouled skies, the filthy waters, the littered earth. As a demonstration, its success was mixed, beyond expectations here, far below there. No one now can know exactly how many took part. We do have an idea how many planned participation, student groups in 2,000 colleges and 10,000 lower schools, citizen groups in 2,000 communities. By one measurement, Earth Day failed. It did not unite. It did attract that broad cross-section of America its sponsors wanted, not quite. Its demonstrators were predominantly young, predominantly white, predominantly anti-Nixon. Often its protests appeared frivolous, its protesters curiously carefree. Yet the gravity of the message of Earth Day still came through. Act or die. We begin our report with Bruce Morton in Denver.
Place for Purple Mountain's majesty. A place where on a clear day, the legend says, you could see forever. The clear days are fewer now, and instead of forever, the view often stops with haze. Next to Los Angeles, Denver has the best climate in the country for producing smog. In this unlikely seeming place, the air is threatened. Earth Day is a focus for efforts to save it.
Bicycles at the state capitol were a Denver symbol. Auto pollution is a major problem here in the country's 17th most polluted city, so high schoolers pedal to show there's another way to travel. The altitude increases car engines' pollution output. It doesn't do a thing to bikes. Somebody in the cheerful, disorganized crowd said, let's clean up, and the several hundred young people did, scouring the Capitol grounds for litter. Cleanups like this went on in many parts of Denver today. Somebody got a wastebasket from the Capitol and said it must be the only one, but there were enough paper bags to go around. Then they left for the teach-in, bikers on bikes, but hundreds of others traveling on foot. Some sang, some shouted, all seemed to enjoy the day. High schools were not closed, but many announced absences would be excused. Corrigan Plaza, the hall, was arranged to seat 6,000, though some planners predicted a half-full house. In fact, it was better than that. Lots of coming and going, but about 5,000 seats filled. Most were young, but not all. Most were white, but not all. A group who'd bicycled across the state gave Governor John Love a declaration supporting a cleaner planet, and the governor signed it.
Earth Day demonstrations began in practically every city and town in the United States this morning, the first massive nationwide protest against the pollution of the environment. In Washington, there was an awesome Earth Day warning from a government scientist. Dr. J. Murray Mitchell said pollution and overpollution, unless checked, could so warm the Earth in 200 years as to create a greenhouse effect, melting the Arctic ice cap and flooding vast areas of the world.
Not very rapidly, but steadily, ever since 1900. And it's continuing to do so. The amount of carbon dioxide in the atmosphere now is 50% higher than it was in 1900. It's still only a little over 0.035%. which is not enough to bother us as far as breathing is concerned, be recognized sometime in the future when you get a little perspective. But I thought that the most interesting scientific event of 1988 was the way everyone started speaking about the greenhouse effect just because there was a hot summer and a drought, when I had been talking about the greenhouse effect for 20 years at least. And there were other people who talked about it before I. But it's enough to trap the infrared waves that Earth reflects into space and to raise the temperature of the Earth slightly. The temperature will keep on going up. And not only are we piling in more and more carbon dioxide in the atmosphere, but we are chopping down the forests of the Earth at a great rate. And the forests themselves are the most efficient consumers of carbon dioxide. I had written an article on the greenhouse effect. It was a year-end article. They wanted me to pick out the most important scientific event of 1988. And I really thought that the most important scientific event of 1988 would only be it. I mean, I didn't invent it. So I explained what was meant by the greenhouse effect, and I also explained that not only were we constantly pumping carbon dioxide into the atmosphere because we're burning fossil fuels, coal and oil and gas, so that the content of the atmosphere, as far as carbon dioxide is concerned, has been going up steadily